In this video, we're going to learn how to model linear situations. So we're going to look at different situations that are linear and how to write equations and graph and analyze them so that you can model real-life linear situation with the equation and graph. And then you can find the domain and range of a real-life situation, which relates back to your functions. Because it's real life, not all the values of x and y are going to be possible in that given situation. So we're just going to do two situations. So the first one, the current temperature of the water is 15 degrees Fahrenheit. You're heating the water on the stove and the temperature is rising 20 degrees every minute. Let x represent the number of minutes and y represent the temperature of water. So remember, when we're writing our equations, y equals mx plus b, we have two variables, your m and your b. Remember, your m is your rate of change, which can either be positive or negative, whether you're going up or down by, and b is your starting. So we need to write a linear equation to represent the situation. So we need our m and we need our b. So what are we changing? What is the water, what is happening? So x represents the number of minutes. So after the number of minutes, or every minute, it is changing by what? Well, if you read the problem carefully and kind of highlight important information, I see 50 degrees and I see a rising of 20 degrees every minute. Well, since it's changing by 20 degrees every minute and it's going up, so my slope is 20. And then your b is, where do you start at? What did the temperature of the water start at? Which is 50. So my equation is y equals 20x plus 50. So here I'm going to create a table of values of 5 points with the situation. So we have x and we have y, but they're not just x and y because we know what x and y stand for. X is the number of minutes, so I'm going to write the number of minutes next to it. Just going to abbreviate. And then this is the temperature of the water. Alright, so what's the lowest number of minutes we can have? Well, at 0 minutes, right when I'm starting to heat, the water temperature is 50. After 1 minute passes, the temperature is now 70 degrees. After 2 minutes passes, the temperature is now 90 degrees. After 3 minutes passes, the temperature is 110 degrees, and so forth. We need 5 points, so after 4 minutes pass, temperature is 130 degrees. So then we need to think of your domain, which domain, remember, is your input, which in linear situations always x. What values of x are there? Well, if you think about it, x cannot be negative. You cannot have negative time. So we can't have negative numbers. And the reason for that, time can't be negative. You can't go backwards in time. You can in the movie Back to the Future, but we don't have the capability like they did. Alright. Are there any values that are not in your range? So if you take a look here, we have 50 degrees is our lowest, and then it goes up. So we can be lower than 50 degrees because that is the starting value. What I don't have on here is the graph, and then kind of keep in mind, if you do graph it, you should label what each axes are, and then you might have to change your scale in a given situation. Alright, so your second situation, you have 16 gallons of gas in your car. When driving on the highway, your car burns a gallon every 30 minutes. So notice how it's kind of a strategy to go through and highlight important information that's going to relate to the problem. Let x represent the number of miles you have driven, and y represent the amount of gallons you have left. Alright. So, in this linear represent the situation. So X is the number of miles, so we know it's going to be Y equals X. Remember, we need to say our M. So it burns 1 gallon every 30 miles. So you have to think to yourself, well, what if I only went 10 miles? How do I figure out how many gallons I have burned? Well, you would do 10 divided by 30. So your equation would be X over 30. Because every 30, if you divide by 30, if you drove 30 miles, and this would be 1, you burn 1 gallon. Another thing you have to think about when you're driving in a car, do you change higher or lower? As you're burning, do you lower the amount of gallons in your car, or do you get more? Well, you get less because you're burning them, so this should be negative X over 30. Kind of go a little more in here. So say you're driving down and you drove 90 miles. Well, that's 3 sets of 30, so it's 90 divided by 3. So you should went down a total of 3 gallons. But if you only went like 70 miles, you go 70 divided by 30. Well, this is negative 2.3 repeating miles, so you go down negative 2.3. There's those decimals in between that you have to consider. And then you also have your starting value, which your starting value here, your B, is 16. All right, create a table of value of 5 points with the situation. Many points you can think of if you drove 0 gallons or 0 miles. Remember, you should label these miles. This is gallons left. You have 16 gallons left in your car. You probably wouldn't want to go up by ones because you're not going to change the 16 very much. You can go up by tens, might be a little easier, or you can go up by 30s to get nice numbers. If you drove 30 miles, that means you burned 1 gallon, so that is 15. If you went 60 miles, you burned 2 gallons, because 60 divided by 30, that is 14. If you do 90, that's 3 gallons, which I showed you over there. So now you're at 13. You burn 120 miles, that's 12, and go up by 30 more. 150 is 11. Again, if you don't understand why it's X divided by 30, really pause the video, think about it, rewind the video until you understand why it's X divided by 30 instead of just X. And then also understand why it's negative and not positive. Is there any values that are not in your domain? Well, you can't have negative numbers, for one, because you can't drive, or distance can't be negative. It is not negative. Also, you only have 16 gallons. There's some point you're going to run out of fuel. So you have to figure out how many miles you actually can drive on 16 gallons. Well, if every 30 miles is a gallon, so how many gallons? How many sets of 30? And you only have 16. So 30 miles per 16 gallons. You take 30 times 16. You get 480. So the highest should roughly be about 480. Now I know that changes based on where you're driving and stuff, but generally speaking, the highest should be 480 miles. So are any values are not in your range? Well, since you have a max of 16, and then you have min of 0 gallons. You can't have negative gallons. So this is kind of your explanation. You can't have negative gallons, or you can't have more than 16 because your tank only has 16 gallons in it. So just to review, remember we're writing y equals mx plus b. We're writing to model. M is your rate of change and B is your starting value. And again, check your domain and range. Does it make sense? What's in it? And that should go off of your function video. Remember to do your reflection so you get credit for watching this video.